Hello everyone. So in the previous session we have started the discussion on pandas, and I'll just maybe give you a couple of minutes of revision so that everybody is on the same page. So what we said is pandas basically is a data processing library. Okay, so why to use pandas? The first thing is because it gives a lot of functionalities of Python. If you are using Excel or something, maybe you can also do some data analysis, maybe you can read files and do a lot of stuff with Excel, but it does not give a programming environment where you can code a lot of stuff and then get the results that you want. So and this is one of the basic reasons why should you use pandas, and I think we had a chat on length why should we use these pandas, and it basically in nutshell it is a data processing library. Now we have seen that in terms of data structures. So there are two main data structures in pandas. I talked about series, and then we talked about data frames. Okay, we had a lengthy discussion on what a series is, how to create a series, and what a data frame is, how to create data frame, what are some common attributes that we use, and what are some common functions that we use. Okay, so now today we'll start our session from this. We'll basically read these files. Now I told you most of the times you won't be creating your data frames. What you will do is you will read the files from your PC, and these files can be of different format. Okay, now first coming to this part, that why do we need this, like data handling for different? Because if you see data is of different types. Okay, sometimes if you say, if I broadly categorize data, so you can have let's suppose numeric data. So numeric data can be there, and then within the numeric you can have integer data, and you can have maybe floating point data, or which we call a decimal data, floating point data. Okay, by integer I mean the values can be 1, 2, 3, 4 integer value, and floating point is 10.5, 6.4, something like that. Okay, then we can have textual data. And this textual data can be strings, and we can have a paragraph, we can have something in the writing. So usually in the tables we have this sort of data. So I talked that in, if you see pandas, so what pandas will have is, pandas in the data is somehow defined as the table, where each column is a feature and each row is a data point, so which we call as a data matrix. So we had something like this. Okay, and then we had in here we had different columns. Let's suppose we talked about famous example. We said if we have let's suppose what's called as iris flower data set. So if we have this data set, so in this data set we have certain features about flowers. So this there are 4 types of flowers. So 4 types of flowers are there. So there are versicolor, virginica, okay, setosa, and something else, okay, which I don't remember the name of. So these are 4 types of data, 4 types of flowers in that. So and the features of each flower are petal length, petal width, sepal length, and sepal width. Okay, and this maybe, let's suppose the last one is the label. This will be our data type. So if you see, each column represents here a feature. Okay, and then each of the rows will have a data point. So this over here will be a data point, and I told you this is called as data matrix. So today maybe we are going to work with a lot of data, that will be having the data. As you know, these machine learning algorithms and deep learning algorithms, they are quite data hungry. Okay, they need a lot of data in order to find these patterns, in order to perform whatever we intend them to perform. Okay, so we need a lot of data. So now if you see each of the features, they can be of different types. So they can be of numeric types. Let's suppose if I say this petal length, petal width, sepal length, and sepal width, all of these are of numeric type, maybe floating point data. So they will take values. Let's suppose if we are taking them in centimeters, we have a unit of centimeters, so it will be 12.4 or something like this. Maybe let's say 1.8, something like that, and there will be decimal point in there. So each of the column in here, that's each of the feature in this iris flower data set, has the data type of floating points. Okay, and then we also have data types can be either they can be continuous, or they can be discrete. So what I mean by continuous is they'll have a continuum of values. So if you see these petal width, it will have a continuum value, maybe between a certain range to a certain range. Okay, we can have values, let's suppose from 1 centimeter to 10 centimeters, something like this. So okay, any value can be taken. It's continuous. By continuous I mean, and there are 2 types of these values can be infinite also. Okay, and there are 2 types of infinity. So I can have a countable infinity, and I can have uncountable infinity. Okay, these types of things we'll read in probability, but here I just want you to know that the values will be continuous. That is, it can have a range of values, like we can have 1.1 centimeter, we can have 1.01 centimeters, okay, something like this. And then we can have discrete values. So let's put discrete values. If we have these 4 classes, so let's define each class with 1, 2, 3, 4. So 1, 2, 3, 4. If these are the 4 classes, so these values are discrete values. So now if you see data in terms of what the content the data is, so we can have numeric data, or we can have textual data, and we can have some other type of data that will read about when we require them. So for this session, probably we'll just read numeric data and textual data. In the numeric, you will see that we'll have this integer data, and then we have floating type data. Then I said we'll have more data. We'll have this continuous range of data where the feature takes a continuous value. Okay, it can take a value from real numbers. Okay, and that's continuous. Discrete values basically mean it can like we had these 4 classes. Okay, and it can take discrete values like 1, 2, 3, and 4. Okay, or maybe let's suppose it can be a if we talk about gender, but there are a couple of hundred of genders now. So sticking to the traditional things, so we had 2 genders, that is female and male. So these things also are discrete. So they'll take value 1 and 2, or 0 or 1 maybe. Okay, or 0 or 1, something like this. Okay, discrete values. Okay. And these things also sometimes called categorical value. Why we have these categories? So if you have 4 categories, we can call them categorical variables also, categorical features. I'm introducing all of these informally, so that if you have some value, and you know, because everything has a separate encoding, these categorical variables features, they have to be encoded in certain ways. Okay, and if you have discrete continuous, you have to encode them in a certain way. Okay, that's why you have to have a notion of what kinds of data and what types of data can be there in our problems. Okay, and that's why the domain expertise become important. So why are we basically studying all of these pandas? Because the first thing that we'll do in any machine learning or deep learning project is that we'll be working with data. Okay, we'll be working with data. I told you that most of the times, maybe greater than 60% times, this time is spent with the data. Okay, and when we were learning about the pipeline of these machine learning and deep learning algorithms, there we saw that we have this data collection step, then we have this data pre-processing step, and then we split the data into test, train, and then we augment data, we clean the data. There's a lot of things that has to be done with the data, because there's a simple principle that you have to remember, that is GIGO. This means garbage in, garbage out. So no matter how much complex your model is, no matter how much better your model, you can be using the state-of-the-art architecture, you can be using the best algorithm, you can use the best coding practice. If your data is garbage, you should expect the output as garbage. Okay, that's a simple rule. That's the reason that we have to spend a lot of time with data, okay, in order to understand this. Now, how to understand this data? If you look it from a machine learning engineer perspective, or maybe the person who is working, they need some domain expertise. So what I mean by this, let's suppose if I am working on a medical data set, let's suppose I am working on a medical data set. So the first thing that I have to go to is to the domain experts. I'll have to ask them, okay, so what features should I collect? Okay, what features are important? Let's suppose we are working on cancer detection. We want to detect cancer. Maybe it is not a generic cancer. Let's suppose we want to detect lung cancer. And now I'll have to ask the domain expert, what are the features that you people look when you detect a lung cancer? Okay, he or she will give me the features that they look in. Okay, that's what the feature engineering part. And once they give me the data, then I'll have to understand each of the feature quite carefully. Okay, this feature basically means this feature means this. So I'll have to do some study on the data, and after that I'll have to analyze data. How many points of this data set, and a lot of things has to be done. That's this phase is called as EDA. That's called as exploratory data analysis. Exploratory data analysis. Okay, and there are roles even in our team. We have people who do this, and if you are working with a large company and they have like suppose team is there who is working on this project, they'll have a couple of members who will work on this EDA. Okay, EDA part. They'll explore the data and they'll do the data analysis. Okay, and because if you understand the data quite well, then you can choose what model to use. You can make basically better choices. So now, how to make this data better? How to basically not have the data which is garbage, and not have this garbage output. So we should have good data which will give good outputs, and we'll choose the model accordingly, and then gain the domain expertise if you're not from that domain. So the least that you can do is understand about the features, and then see what are the range, and then maybe you have to handle missing value, and there is a lot of stuff that you have to do. and that will be done once you do this explore data analysis, once you explore the data and do the analysis of the data, and after that you are in a position now you can play with the data. Am I clear with this part? Why are we doing this in Pandas? Because Pandas is the library which maybe more than 90% of the people use in the machine learning community. Is this clear? Why are we studying Pandas, and why are we now looking at different methods, how to deal with these stuff? Is it clear? So after we are done with these libraries like NumPy, Pandas, Matplotlib, Seaborn, then we'll have a separate lecture on expert data analysis. So we'll take some data set and we'll analyze the data and we'll see the different things that can be done on the data. So we'll do that separately. But here you should at least know the things that can be done. Okay, I always tell you that do not remember any of the syntax, please. Okay, do not maybe memorize these stuff, but you should know that these concepts do exist there. Okay, so that is my point, and you should also keep that in the memory, that you will be using hundreds of libraries in your career of computer science, and if you keep on remembering everything from every library, it will be very difficult. Humanly it will be very difficult. So it is better to know the concepts, and then documentation is always available there. You can just go to the documentation and just, it's one Google search and maybe write in the Google how to do this, it will show you the documentation. Okay, but as a person who will be daily working with this, so you must know these concepts do exist there. So if you do not know the concept, then it's a problem. That's the reason I'm telling you, do not memorize, rather know the concepts that are there. Okay, and that's the realistic way to learn also. Okay, now coming to the Pandas part again. Now what we'll do is, we'll see, okay, the first thing that we'll see is we'll see some methods that we have seen in the previous session also. I'll just maybe quickly revise them, and then we'll maybe see additional methods. Because anytime you read some data or anytime you have some data, what you will do is you initially do, okay, what are the features, what is the header, what are the different features of the data. Okay, so let me go to the code window and I'll show you there. I hope the code is visible. Okay, now what can I do is I can maybe create first a data frame, and then we can maybe again have these head tail methods which we saw in the previous session, and then we'll see those head and tail methods on the real data set. And it has been collected from an online repository which is called as UCL repository. So the first thing is, what I'll do is I'll import NumPy, because you know that NumPy will be used anytime. So I'll not take any risk. I'll import NumPy as NP, and then I'll import Pandas as PD. Okay, so these are the two things that I'll import. Now what I'll do is I'll create a series. Let's suppose I'll create a series which is called S. I'll create a series. So how to create a series? You know, PD dot series. Okay, and then what I have to do is I'll give the data, and then I have to give the index. So what I'll do is, now I'll give the data. So what I'll do is I'll create random numbers from NumPy. NP, you know that there is a random module in NumPy, and dot rand. Okay, and what is the, how many random numbers I do? I want, let's suppose 5 random numbers, and then let's suppose what is the index? I can say index is equal to ABCD. Index is equal to, what I can do is list of ABCDEF, DE maybe. These are the 5 numbers. So I can, so this list will make the list of things. So if you want to just test it, what will list do? So what I can do is I can say print list of ABCDE. So if I print this, you can see it made a list of this ABCD. I would have written ABCD separately, but it was quite easy to me that I just wrote a list. Okay, this is called as typecasting. You have a string, you want to change it in the list. So I did typecasting over here. So the indexes is A, B, C, D, and E. So now if you see this S, so if I, let's suppose, print this S, now you can see, oops, I'll have to run the cell. So here you can see this is a series, and index is A, B, C, D, and E, and then we had the corresponding random values to it. Okay, now the first thing is, can we, let's suppose, do something over it, and if I just want the features, let's say this is a series. If I want to create data frame, I'll create data frame so that it is more clear. So I'll create data frame. Again, how to create data frame? You know that PD dot data frame. This is the function that we'll create. Again, we'll use NumPy as a random module, NP dot random dot rand. So what I can give is I can give the size. I'll say, okay, create maybe 8, 3. 8 means 8 rows and 3 features of this. So then what I'll do is I'll say columns. I'll put column names as ABCD. Let's suppose I'll put list of A, B, and C. So if I now print this df, you can see that I created these are random numbers. Okay, and we have 8 of these rows and 3 of these columns. Everybody is with me? Should at least maybe give some reactions or maybe create some noise so that I can hear that you people are listening to me. I'm not releasing sleeping gas.
Yes, we are. Yes, we are listening to you.
Yes, yes, good. So again, coming back over here, so if you see this, over here, so okay, so can I write? It's not visible, so it should be visible. Give me a sec or something. Yes, now it is visible. So if you see this, so what I did is in here, so I said give me 8 rows and these 3 columns. So I told you that consider this is the data matrix now. So each of this ABC, these are features. So here if you see, these things are features. Okay, so they are features. And each one of these things is a data point. So these things are data. So each one is data point. So now if you see, these are indexes. By default we have 0, 1, 2, 3 index, something like this. So if you want, you know that we can create manually, we can create these manual indexes also. Okay, so this is my data. So now if I have to create manual index, let's suppose I'll create manual index of time. Let's suppose I have collected this data. So this is day 1, day 2, day 3, something like this. So how to do? Pandas also gives me flexibility to create indexes. So what I'll do is I'll say index. Maybe I should create it first and then I'll use it. So index is equal, so what I'll do is I'll say pandas dot, there is date range is a function. Okay, date range is a function in pandas. So what you can say is, you can say, okay, give me, let's suppose 8 days starting from, what is the today's date? So maybe I'll write I don't know, 29 9 and 2024, something like this. And then I'll say give me the how many periods I want. I want it for 8 periods. Periods is equal to 8. Okay, and there is a lot of arguments that you can read about. You can go to the documentation to see this date range. Okay, first I'll see what will be printed by the index. Okay, I first want to see for myself. So what will be printed for the index? Oops. So now what I'll do is I'll just print this index. It's a good practice to test whatever you are doing is, so that there are no surprises afterwards. So you can see now there are dates. Okay, now the dates are there. So 24, 9, 29, then we have 30, then we have 1, 2, and it basically goes from 29th of, I think, September, if I'm correct, and then it goes to 1, 10, and then 2, 10. Yes, I think this is the one I want. Yes. So now what I'll do is, because I have these 8 data points. So if you see this DF, you see this data frame. So over here I had these default indices. Default indexes 0, 1, 2 till 7. So if I want to create these indices by my own, so I'll say index now is equal to index. Okay, now if you want me to print this df, now you can see that the indices are changed and we get the date indices. And now you see this on the above there is nothing. So on the above I mean it is not named as indices. Okay, because by default it's called index. So if you just say df dot index, you can see that we got this index. Okay, so if you just print df, so you'll get this data frame. So this is by default the index. Okay. So I created a data frame in which I have 3 features, A, B, and C, and I have the corresponding dates, and consider this each as a data point. Let's suppose this is a time series data, so which changes with time. Is a time series data. The time series data can be from stock market, the data can be from weather forecast, and anything that fluctuates with time. We call that time series data. There is a time element, time axis involved there. Okay, so consider this as a time series data. Now I told you, now in order to inspect this data, so I created this data on my own. I knew what are there, but sometimes you'll read the data from the files. So there you sometimes what you will do is you need to know about what is the header there. Okay, what are the features that are there, and how many data points are there, and what is the data type of these things, and you want to do this different analysis. So I told you, because if there is, let's suppose, hundreds of data points, what you can do is you can see df.head. So df.head will give you by default 5 points. So now if you see is, it gave the initial 5 data points, A, B, C, D, and this is one function. And by default, head takes an argument where you can specify how many rows you want. By default, it's 5. Okay, if you want more data points, you can say 6. So now if you print it, you can see one more point got added to here. Okay, and there is the one more method, that is df.tail. So that gives you the tail. So if I say df.tail, and again the thing, it will give me the last. From the tail, from the backwards, it will give me these data points, last 5 points, starting from n-5 to last n point. So these are the last 5 points, and I can again use it in the same fashion. I can tell it to give me only last 2 points. Okay, so it can give me last 2 points only. So these are the 2 methods that we saw. Why are they used? Because in order to understand data, let's suppose you are quite new and quite fresh with the project, and what you want to do is you want to understand data types, and you want to see what are the different data, and you want to see the structured data, and you won't see the whole. Maybe you don't want to open the whole of this data frame. You just want to maybe see the first couple of points, 10 points, 20 points, 5 points, and then you can just use this df.head. Or if you want to see the last points, so what you can do is you can use this df.tail. Okay, syntax is pretty clear from this. So now there are some other methods also. So there are other methods. Let's suppose now you want to check the data type of all of these ABCD. You want to see what type of data is there. Okay, what type of data? So it can be numeric, it can be a string, and what you want to do is you want to see all the features. So what you can do is you can just type df.dtype. So df.dtype. So if you see this now, ABC, A is the float 64, B is again float 64, C is again float 64. Float 64 basically means is a floating point number which is taking 64 bits in the memory. Okay, this is float 64 type of data. So if you can maybe add one more column, you can add one more column like this. So let's suppose we have this df. I'll keep on creating new cells. So we'll say df, and I'll create one more feature. This is how to create one more feature. Df of, I'll create a new feature name. Let's suppose we have these 8 names. How can we do this? So we can assign a list of names maybe to it. So list of names will be Mahmood, something like this. And then I'll say maybe some other names, Asif. Some other name maybe Tazmeen. Okay, and then we can have other names. Oops, sorry. I misclicked. So I can say Anwar. How many names are there? So I can say ABC. Now I'm getting out of the names. So I'll say DF. So 1, 2, 3, 4, 5, and 6. Maybe it will take NaN also. So df.name, if I do this, so it should be 8 actually. So I should give 8. It is forcing me to give 8. I'll give something like this. Something like this. Okay, now if I print this df, so I added one more column into that. So if I print df now you can see I added one more column of this name, Mahmood, Asif, Tazmeen, Anwar, ABC, def, ERE, something like that. Now what I want to do is, if I now want to see the type of the data type of each column, so again I'll say df.dtypes. Okay, there's an attribute you can clearly see. A is float 64, B is float 64, C is float 64, and name is an object. Okay, name object basically means everything that is not maybe a floating. If it was an integer, let's say it'll have told me integer. So this is treated as an object. Okay, these names will be treated as an object. Everything clear so far? Is it clear? Any questions? So now we have refreshed what we studied in the previous class, and we saw other methods also. We saw we can check the dimensions or the shape, and then we can say df.shape. Okay, and we also checked a lot of arguments. Okay, so df.type, we had df.describe. Okay, and then it gives a description. So I want to also check one more thing. Is this allowed in here? So I'll see what are the methods that are applicable on this dir. So these are I just wrote this dir. So what it gives you? So it gives you all these are the methods: data frame, copy, value counts, values, and we'll see what these value counts values are. Okay, we'll see all of these methods. So this dir is a simple method to get to know what are the attributes and what are the things that I can apply on these. Okay, you can just apply this dir to see what is applicable on the data frame, and it's a generic Python function, this dir. So we'll maybe see it some other day. Now coming to the pandas IO. So I told you most of the times you won't be creating your own data. What will you do rather? You will read the data from the file, and then you will have to introspect the file. What are the features? What are the different things that are file? Okay, and there are different formats that pandas support. Okay, the most famous format that probably people use is CSV. Okay, in the text, in text format we can have CSV, we can have FWT, and they're called as FWF files. We have fixed width text file, and then we have JSON files, then we have HTML file, we can have LaTeX files, we can have XML, we can have clipboard files. All of these are different types of text files which are supported by pandas. So I'll say in text, so what are the supported formats? What formats can you read? Okay, you can read CSV files. Okay, and CSV basically means comma separated values. So where the values are these comma separated. Then you can read FWF. FWF means fixed width text file. So each thing will have a fixed width. Then we have these JSON files. Many of you people who are working with web development, they know what JSON files are. Then we have HTML files by which we can make this web page. And then we have LaTeX. Many of you people might be using LaTeX to write their assignments, and maybe this is how we read books. This is the format, and then we have XML. Okay, even we can read Excel files also. So we can have clipboard types. All of these are mentioned in the documentation. Okay, I have not remembered these. Okay, so you can just go to the documentation and see what are the file formats in text that pandas can read. Okay, this is the text format, these type of format, and then we have binary format also. Okay, in binary format we have different file types. Okay, in binary type we can have MS Excel format. So where you have this maybe X LS or something like that, and there are a lot of these binary. I don't want to enumerate all the details, but I want it supports text files, it supports binary, it also supports SQL. Okay, and it supports SQL databases. If you have an SQL database where the things are stored in relations, they're stored in tables, it can also read that. It can read textual data, it can read binary format data, it can read SQL, and it can also read what's called as BigQuery. Okay, BigQuery, again, it's a Google BigQuery database. If you have worked with a lot of data, like recently I was working with data where we had data which was of the range of terabytes. Okay, we had to work with this BigQuery data. So now if you see, it supports text data. There are a lot of formats which I told you, some of them. It also works with binary data. Okay, in binary I told you there are this MS Excel format, there are open document format, there is something called HDF5 format. Okay, and there is Feather format and a lot of formats which even I have never used in my life. So, and then there is SQL data, okay, which is SQL database, a structured query language database. Then you have this BigQuery data. So this is what is given in the official documentation. So these are the data formats which it support, and I told you within each of these there are many subfiles also which it can read, and for all of these it has defined methods. Let's suppose we'll work with CSVs, that's comma separate values, where you have these comma separate values and we want to read the files from there. So you have a function that's called as read CSV. Okay, I would show you that right now. Now we'll see how to perform IO, because most of the times you'll use this. Okay, please be attentive here, because any of the times you'll not maybe create your own data. What you will do is most of the times you will some way or the other read the data from the maybe somebody has collected data on your behalf, or you have collected your own data, and then you will read these files from here. So now coming to this, what we can do is now we have imported this pandas and numpy. So I'll say my data frame, I'll call it data. So is equal. So what I'll say is pd dot read CSV. Okay, now you can see how these are the functions. See, read SPS, read SQL, table. There are a lot of these things. Oops, sorry. Thank you for telling me this. So I told you, if you see this, what I'll write is I'll write data, and then I'll assign it. I'll write pd dot read CSV. If I just say read, you can see these many functionalities are there. So read SQL query, read SQL, read SPAS, SAS. So, but I'm interested in read this CSV file. Okay, now I have to see, I have to give it the location where I have stored a lot of data sets. So I won't be able to probably show you all data sets, but I have one data set. I'll just copy the location of this. So here I'll give the path name. Okay, I have given this data sets heart disease data set. So here I want to see if the heart is fine, if heart has some disease. So if you see, this is the data. So I read it, it perfectly is reading. So I'll now have to see it. So what is the function that I'll use? I'll say data.head. I don't want to see whole the data. I just want to see some of the data points. So each of this data is from a patient. Okay, age is this much, sex is either 0 or 1, female or female. Then this is maybe CP, or this is rest blood pressure, cholesterol. I have to again look into different features. And for each data set, you'll have to look into the features. What are the different features that are in the data set? Okay, these are different features. And if I see, now the first thing I saw the data, and if I want just the column names, so I can write data dot columns. So if I now print it, it will give the column name. It will say the columns are age, sex, CP, this rest blood pressure, sugar, cholesterol. Maybe this is fasting blood sugar, and this is rest ECG. When it's resting, what is the ECG? Okay, and I don't know this, and maybe slope, CA. These are all medical terminologies, and you will have to look into the different features. What are the features that there are? So these are the columns. Okay, so each of this is one patient's data. If you talk about one row over here, so one row gives you the one patient's data. Okay, is it clear? Now the thing is, if you again want to see what the types of the data, so what you can do is you can say data.dtypes, data.dtypes. Now you saw that. Now we have age is int 64, sex is int 64, CP they are int, and something is float 64. Most of these are numeric data. We don't have object data in here. Okay, most of these are numeric data types. Now if you want to see how many males or females are there, okay, you have this sex and you want to see how many males and how many females in this data. Maybe initially you want to see what is the length of data, in total how many are there. So you can say data dot shape. Data shape. So this tells you there are 303 patients and each patient has 14 features. So this you can write it, and during every stage you have to write these things. So if you have to present somebody, okay, what is data is telling, so what you have to do is whatever analysis we are doing right now, Okay, you have to write it. There are 303 patients, and each patient has 14 features, and you have to write about features also. Now, if I want to see how many males and how many females are there, so what I can do is I can say data. I told you about how to select these things. So how to select? So you can maybe select sex if this is there. So I just want to see if it prints the right thing. Yes, it does give it. So there is one more thing that's called value counts. Okay, if I see value counts, this is the method. So it will tell me sex 1, 206 and 0, 97. That means maybe if 1 is the male, so we have 206 males, and 0 we have 97 females, something like this. So this is one more method, value counts. Okay, I just want to tell you how to go initially. When you read the data, I'll go back. So when you will read this data, so this is how we read the data in here, and we read it, it was a CSV file. And if you check the documentation of this also, so read CSV also, you can go to document, you can define the delimiter, you can define a lot of things within the CSV, but this is the most simplistic way where you can read the file. And then in order to see what are the contents of file, I just checked this detail and head, so that I can see maybe first 5 points and the last 5 points in the data frame. This is the data frame. If I want to confirm that this is a data frame, what I can do is I can say print type of data. So I want to see what type of data it is. It should be a data frame. So now you can see that this is the data frame. Okay, so everything now which I read with this read CSV, it is a data frame. This is my data, and I saw these are the columns that are there, and each column has this data type. Okay, then if I wanted to see how many data points are there, I just use this shape, dot shape. I said there are 303 points, and there are these 14 features. And if I want to see what features are there, I just said print, I'll say data of dot columns. Okay, these are the columns that are. That's why it's this index column. This is now getting as a index. So index is age, sex, CP. These are the features that I have. Okay, then I said if I want to see how many people have a sex male and how many are female, what are the basically counts, so I'll just select that first. I'll select the column of sex, and then I'll perform this value counts function on that. It will give me the count. It will give me 1 is what 1 if it means male, then we have 206 males, and 0 if it says if 0 is used for females, then we have 97 females. Okay, these are the basic things that we can do on a data on the data frame. Maybe if we read it from the file. This is the first initial things that we'll do, and we are going to learn a lot of methods coming soon. So are you understanding everything so far? So what I said if you have to check the methods and the attributes that are possible, so you can just call this dir function on this data frame, and these are the methods and the attributes that are possible that we can maybe call on this data frame. But in order to, if you want to read each one of this, so what will happen is you have to go to the documentation. You just have to Google it and see what are the parameters it takes and how to use this function. So then you can, once you need it, and you can maybe search it up and then do the things that you want to. And otherwise there is no point in reading whole the thing. So it is better to know most frequently used things. Okay, that's what my focus here is. I'll more or less tell you what are the things that you use 90% of the times. I won't tell you, okay, we won't go to maybe, let's suppose this power and plot, we'll maybe we use them, maybe n unique, n smallest, and maybe not null we'll use, not na we'll also use, but many other things we won't touch. But if you need them, you have to go to the documentation. That's why when people have coded these things up, they have written the documentation. You just go there and see what are the parameters it takes, and then accordingly use it in your own ways that you want. I hope this is clear. Okay, now once I load this data, so the first thing is what I want to do is I want to show you how to select data from it. Okay, now once you have the loaded file, so what we'll read next is how to index and how to select. Again, these concepts are repeating because we have seen in NumPy this indexing and slicing. So we'll see selecting and indexing. These things should look pretty simple to you. If you are coming from NumPy, so we more or less we know how to select and how to slice these things. So here we'll maybe have different sort of things where we can the syntax will be different, but the underlying concept will be similar. Okay, so we'll now select these things and we'll index, because now if you see this data frame, it's like this. Data frame is like this. So each of these things are features, and these are my features, these things, and this is my data point. And now sometimes I want, so I'll give the technical names also. These are called as index, and these are columns. So if, now you'll have to select certain columns, and you'll have to select certain indexes. So and from that you can do something with the data. So now we'll go to how to access these rows. Okay, how to access these indices. Okay, we'll go there. So now if I go back to this coding window, and I'll show you that. It should be pretty simple. Now again, see if the df is loaded. I think df is there, so you see df is there. Oops, df is the original data that we create. We have this data dot head that we read from the CSV file. This is our data. Okay, now what we'll do is, if we want to select, let's suppose this index, so what I can do is I can say data dot iloc, that is location, and then I have these square braces. This is the syntax. If you want to select at a thing at an index, let's suppose I want to select index 1. So now if you see, this is the data point. Age is this, sex is this, CP is this, and everything is there. So this is called as indexed location. If the index is giving 0, 1, 2, 3, 4, because you know that index can be anything else. Index can be date, index can be time, index can be ABCD. You can have custom indices also. So that's why if you don't have this default index of integer, so what you do is you just use data.loc. Okay, that time you use data.loc. Okay, this is what you use that time. And again, you will use the same thing, and then you will use whatever index is there. If your index is A, right now we don't have A index, so it should say key error. It will give me key error because we don't have this index A. If I just remove this and print this, so I am saying that a data point is named A, so but it is not there. So if I just run it, it should say this is key error. So that is why I raise key error, because this key is not there. So if I had this A in there, so most probably we'll get that. So this is .loc and this is .iloc. These are the two things. Okay, then you can slice it also. Okay, I'll now focus on this I location. Oops, I hate these errors when they pop on the screen. And now what I can do is I can say data dot I location. Now again, the same syntax is there. We have done it at length in NumPy. So now if you want to slice, if you want first 5 points, so you can just type 5. So you'll get first 5 points. You see it. And if I want, let's suppose 1 to 5, so I'll say give me point number 1 till 5. And again, if I want step size also, I hope it supports step size. So step size of 2, same. Okay, you get 1 and then you get 3 point. Okay, this is the start index and this is the end index and this is the step size. If you want to jump, you start from 1 and then jump 2 steps, went to 3, and then jump 2 steps, went to 5, but 5 is excluded. So again, this is the same concept that we have seen. So now you have to remember two things. There is this iloc and there is this loc. So location is label based. Okay, initially we had .iloc, that's called integer location based. Okay, loc means location, I means integer based location. Okay, so I'll just write it somewhere so that it is in the records. So we have these two things. We have .i location and then we have this .loc. So what is this iloc? Iloc, I said, is called as integer location based indexing. Integer location based indexing. And then we have this loc. Loc basically means labeled. Okay, label based indexing. Okay, this is label based indexing and this is integer based indexing. If you want to use the integer, because I told you if you just create data frame or if there is no index defined within the file, then what will happen is it will have by default those integer locations which will start from 0, 1, 2, 3, 4 till the number of points we have. Let's say if we have n points, the last index will be n minus 1. Again, now if you have index which you have customized, you have given it maybe a date, maybe some time, maybe ABCD, maybe a string name, it can be somebody's name also, so you can just call that LOC and then within these braces you can call them. Okay, and you know the slicing, and I think I don't need to give you the thing about slicing. So again, if I just select now I can, with this LOC I can select only specified columns. So again, if I have to do this slicing, I think this should be pretty clear from the NumPy. That's why we took so much time in understanding NumPy. So that's why we had this data. So I'll use .loc. Now let's suppose I want to use all of these data points. Okay, but I only want to use maybe 3 columns. So what I can do is I'll say .location, .loc, and then I'll say this colon, and I'll put comma. So basically this first will tell me, because it has two axes, axis 0 and axis 1. Okay, axis 0 by this comma. Before this is axis 0 and this is my axis 1. I'm saying select all the points and then select only few columns. Select only few columns. Let's suppose age column. Okay, and then maybe gender column. These 2 columns let's select and select it for all the points. So I hope everything should get printed. So if you see, it printed these, so I should print head. Is it clear? So you see data, then location, and then this loc is just a syntax thing, and rest this we have discussed in detail. So here what we have 2 axes, axis 0 and axis 1. Okay, just for the sake of again completion. So if this is the thing we have, So we have two axes over here because there's a two-dimensional thing. So here we have this x is 0 and this is x is 1. Okay, so when I write something like this, when I put loc, okay, and then when I put comma in between, so here if you see, this is for this index, this is for the index, and this is for the columns. Okay, so I told it by this colon, if I have this colon over here, so if you see this, so I dropped a colon over here. By colon I mean select everything that is there. Okay, then select two columns. So these are my two columns, age and sex. So now if I want to, let's suppose, select first 5 points, maybe alternate points, so I can again use the same thing. Okay, same concept. So I'll say select from 1 to, let's suppose, last point is 10, but only select the even index point. Okay, even index point is, let's suppose, I'll say 2. So start from 0 rather. So start from 0 and then 2, then 4 until last should not be given. So and then give me these columns. So now you can see the 0 point has been taken, then second point has been taken, fourth point has been taken, 6 has been taken, 8 has been taken. Okay, so this is called as this is dot iloc. And then we have also boolean indexing. So again, seen it in NumPy. So here just we need to see how to use it. Let's suppose now I want to select the people with the age greater than 50. So how I can write it? I can say def df. So df and then select the age column. So I'm selecting the age column. Then what I'm doing is I'm saying, now it'll give me the age. So I'm saying now take age column, take all the age column, and based on this, if this age, now I can set a criteria on this. I can put a condition over here. Okay, I can put a condition on this. So I'm saying I want the people whose age is greater than 50. So I'm saying select all these things. df.age is greater than, let's suppose, 50. Okay, and then this, if you see, will create a mask. This will create a boolean mask. So in order to show you, so if I just go over here, so if I show you this, so it will create a boolean mask if you see it. Oops. So rather I should. So what is the problem that it's showing? That's why I hate these errors. Is age there? Age is not there at all. Is it there? Key error. But age is there. There is some issue. Let me fix it. So df, I'll first see why is it giving the error. And it sometimes does give error because of, oh, it's showing age is not there. Now you'll have to see how what is that. Then maybe age is misspelled or something like that. So what can I do? This is data actually. So I am using df. To be careful. So because I have two data frames selected now, I have df and data. So data is in this, age is in data. Okay, silly mistake. So now if you see, this age got printed. Now I am saying, I am giving a condition. I am saying if age is greater than 50. So what it will do? It will create a boolean mask. It will say true, false, true, false. For the people while it is true, it will show true. So if I just print this, so you can see true, true, false. So this is that mask sort of thing. Now I want to apply this mask on the whole data. So I am saying data. Okay, now it will show me only those points where this is true, and for the other where it's false, it will not show these points. So if I just do it, so now you saw these points. Okay, and you see this is the thing. So data age is greater than 50. So there are, if I want to see how many points are there, I can just call shape. I said out of these 303 patients, 209 are above 50. Okay, so that's how I do this, called as condition based selection, or it's called as boolean indexing. I said this is a boolean mask. How many of you remember this from NumPy? How many of you remember this from NumPy? I hope you should, all of you should remember this, because we spend a great deal of time in understanding this. Any questions on this? Okay, so here if you saw, here we had this boolean mask, and you can maybe add more conditions to it. You can add more boolean mask, and you can add more conditions. Let's suppose if I want now, let's suppose age is this, and I want only, let's suppose, male. So what I can say is, I can say and then and. Okay, I'll put this logical and. I'll say data, and then I'll say maybe let's suppose sex. And I know there are two values is equal to 1. Okay, oops. So now I have to check it this if this gives me the boolean values. Okay, otherwise I'll have to put ampersand ampersand. That's why you have to check these things. There is some error. Is there an error? No, there is not. So here I'm getting this. So I should rather write this and. So this should not be logical and. I'll say bitwise and maybe if it does the job. It is giving some other errors, but I think it will take me some time to debug this error. It is better not to debug in the class, otherwise we'll keep whole class for debugging. But I'm saying you can use these conditions one after the other. So you have this data and this is true, and maybe I can create another mask. So can I say data and I'll create age, and then I'll say greater than 50. There is some, oh, I am writing anything, so I should write it like this. And these are the two things. So now I need to see, can I perform these AND operations on these two things? If not, what should be that? What should be done? Okay, can I perform AND operation on these two things? The truth value of series is ambiguous. Used a empty, a bool, or a item, or a any. Okay, I think we cannot do it on the series, so this operation is not valid. Okay, we cannot put AND over here. Okay, we need to look at a different thing. So, but I hope that you got the concept. You said we said that we can create a Boolean mask, and with this Boolean mask can be even without this. So you can say I want to create a Boolean mask like this. So what I'll do is I'll create maybe a mask of true and false. Let's suppose I'll say true, something like this, true for first mask, and then false. And you can create basically custom things like this. You can create custom, and then you can apply this on your data frame. And maybe for all the points I won't create it for all the points, so you can create it custom and then convert it into the type of this that you get. So if you want to just take the type, okay, so if you just want to take the type, you can press type over here and then see this. So it is a series, so you can create a true false thing of series. So you can just say true false, and for all the points, and then you can just wrap it around pd.series, and then you can also manually use it. Okay, so here it won't work. Why? Because I am not creating for all the points. So what you should do is, so if you have to manually create sometime, let's suppose you want to mask in a certain you don't have a condition, maybe you just want to mask some points, and for that you want a Boolean mask that you want to create custom mask. So you can just create maybe a list and then convert that into series and then use that within this data. Okay, so within this data you can use it. So this data frame. So we had this data frame as we are using. We said df of something age is greater than 50. So in here, this part, if you see it, oops, I should write it outside. So this part, if you see this much, this created a Boolean mask. Okay, and then you applied this Boolean mask on the whole data frame. Okay, that's why if I did log dot head, it gave me those points for which the age was this. Again, I'm getting so many errors. Oops. So it is data. Again, I am changing this df data, so it is again the problem. So maybe I should remove this. You guys should actually remind me that we have this data frame that is not storing age. So this is that. So I'll just remove it. I don't have data frame at all now, this df, because I have stored everything in data. That tells me that you are not listening carefully. Okay, now if you see, this is head. So were we initially using this df only? So we're using something df or something. Okay, we'll see that separately, because we should not waste time in debugging the code, and it is a huge pain to debug the code. Sometimes you'll write code in maybe 30 minutes. It'll take 1-2 hours to debug the code because there'll be a slight mistake. So it is better not to do it live, and maybe whenever you do these things at home, then you have time to debug this code. Okay, so all in all, what I said is, so we had 3 types. Coming back, so we had 3 types of indexing or selection that we studied so far. The first thing is that we saw is, we said dot location, dot loc. Okay, then we had dot iloc. Then we said we have Boolean indexing or Boolean masking. Okay, and then what you can do is you have also some other things, for example, like dot at. Okay, then we have I at. Okay, and there are a lot more methods than this. So I'll just show you this again. This is label based indexing, but this is called as label based scalar indexing. If you want a scalar, let's suppose you want the 0th, you want to access the first row of the age, and you can maybe access it like this. You can use this at. Coming back to this code, again, I won't enumerate all the methods, but you should know there are methods that do exist. So data of. So what I'll do is, again, I'll use this at method. So I'll say df dot at. Okay, dot at, and then I'll say, let's suppose I use 0 element, and then I'll use this age, age. So if you now see it, it shows me this is 63. The age is 63 for this. So 0, age is 63. So this is again the same thing. If you want to have a scalar value, if you just want to take, that's why it's called as integer location scalar access. So if you just want one value, so for example, I want cholesterol value for patient 5. So I'll say cholesterol value for patient number 6, which is basically indexed at 5. So if I run this, it will give me scalar value. So this is 236. This is that. If you want a single value, then you can again slice it in different ways. Let's suppose you want a data frame, so you want to select say age and sex and cholesterol level, and then you want to select from point number 1 to point number 5. So what you can say is, I'll take age, and then I'll take sex, and then I'll take some other column, maybe CP. If CP is there, it should be there.
Again, it is DF.
Again it's DF. Yes, yes. You should keep on remembering me. So this is data. Okay, because I'm accustomed of naming things data frame DF. Thank you so much. So otherwise, again, we'll run into some error, and then I'll tell you I won't debug the error. So I'll just move on. So it is better to remind me that this is the wrong thing. So I use DF. So rather than that, I should use data. So now if you see this, we have this age, we have this sex, and we have this CP. So what I'm saying is, if I just type, let's suppose head. Oops, I want to type the head. So this is these things. So I took age, and I took sex, and I took CP. So what I'm saying is, now what I'll do is I'll just slice it. I don't know anything. Again, you can use this indexing. I think you are now experts in this because we have done extensive things, these things in Python. So if I want just take maybe maybe 3 points, initial 0, 1, 2 points. So if I just do it, it will take these points. Okay, and you can maybe store it again. You can store it in some new data frame. So you can say a new DF. Okay, you can do this also. Then you can manipulate this new DF, whatever you want to do, new DF. So whatever you want to do with this, you can now do with this. Okay, this is one of the slicing methods. So you can just add these things over here. I think these things you are experts at how to do this. So now I selected some particular columns. So among these columns, I want to select only certain, let's suppose these data points. Okay, this is called slicing a data frame. And we saw dot at also. So we can also have dot I at. Okay, there are a lot of methods. I won't these the things that I'm saying are not exhaustive. There are, I think, more methods than this. I have just showed you what can be possible on a data frame, but I just showed you some of these things if you want to do it. I think, and these will be because sometimes you will need to select a column, you will need to select a certain thing, you will need to Boolean mask, and then you need this I location, you need location. You should know that these concepts do exist there. It's not necessary that you know the method names. You just have to search. You just have to search how to apply Boolean indexing. You have to search, okay, what is the difference between iloc and loc? Okay, how can I use this? And if you keep on like practicing it, you won't need the remember. You won't need the rote memorization part. You have to remember all the method names. Okay. So I also showed you I8. So I8 again is this is integer based now. So initially we were doing at only. So if you see this at, coming back to at, so we had this data. Then we said data dot at. So in that, what we were doing is we were giving the this location, and then we're giving the column name. Suppose like this. This is again scalar. Now what if I don't want to use this age? Okay, what if I only want to use integers? Then I should have I at as we had location. Okay, then we had this I at also. So then we have data dot I at. Again, if you see this, so you can say I want 0 and I want 1. Okay, this is again the 1 element. So if I say data dot head, in order to tell you what these things are, data dot head is here. So this is the 0th element, and this is the first. You got the 1. And if I let's want this cholesterol, this is 0, 1, 2, 3, and 4. I can write 4. I can write 4 over here. So if you see 233. Okay, now two things. I'll again clarify these two things because there are two important concepts. Irrespective of this loc and I at, I'll tell you what these two things are so as to summarize this. So now what you have is you have index names. So, okay, you have index names that can be custom names like some string A, some string B, something like this. And then what you have is you have column names also. Column names. Okay, let's suppose you want to select something. You want to select something based on the name. Based on the name. If you select based on these names. So what you do is you directly use either .loc or .at. Okay, use this .loc or .at. This assumes that you basically know these names if you know the names. Then we have correspond .iloc, and then you have .i8. This is integer based. Now if you want to remove this name part, you just remember, you say, okay, I don't have this names of columns, I don't need to have the index names. So what I can do is I can just give you 0, 1, 2 as we have in the array. So if you remember how to visualize 2D matrix, is something like this. This was one of the visualizations we studied in NumPy. This is 0, 1, 2, and 3. This is 0, 1, 2, and 3. Okay, this element over here, 0, 0 element, 0, 1th element. Okay, and similarly something like this. This is 3, 3 element. Okay, so this is the visualization we studied, and we studied again tree-based visualization there. Okay, in here this is important. So if we don't remember the column names, so you roughly want to say, okay, on the second column I want this element, so you can just use this I8. Okay, this thing can be used. Okay, this add can be used if you know the column names. Again, the same thing with the location. If you know the index names, you use loc. If you don't know the index names, you can use dot iloc. Okay, and this is why we have added this I over here. I basically means integer based. It is based on the integer. Any questions so far? So now if you see this, we have seen a lot of things by which we can assess these columns. So I'll just maybe write it over here so as to show you the complete picture. So we first saw how to assess columns, how to access these columns. So we said we'll use bracket notation. Let's suppose if we have data frame. So what we did is we use this bracket notation and then use the column name. Okay, that was the column name goes here. Column name. Okay, and after that, so one thing that I didn't show you people. So even if you want the if you want to access column name, you can use one more way, that is data dot. So you can just add the dot. So going back to coding, I'll show you that. So you guys, sometimes if you don't want to put this maybe these strings and this bracket notation, what you can do is you can again do it like this. So let's suppose I know this is my data dot columns. If I want to see it, so these are my columns. I want to see the age. So one method is which I showed you, that is data. If I want to select the columns, so you just put the age over here and then you will see this is the age. But you can again use it like this. You can still use it like data dot age, okay, as an attribute. Okay, this is again the same way. If you again see, so more or less these things gave us the same output. Okay, this is one more way to assess these columns. So coming back to this, so I said the first thing that we saw is how to assess columns, and we saw this notation. We saw this column name is not a bracket notation, and then we can use this dot. Then in order to now get the rows, okay, this was assessing columns, then we had to assess rows. We have to access the rows. So in order to access the rows, what we did is we said we can use dot iloc, okay, and dot loc, and these are two things. So this is called as integer based and this is label based. So you can, if you have a name for that, and this is accessing rows. So here we have these indices. So for these indices we have given certain names. So if the names are there, we can directly use this iloc, or if there are no names, we just want to use the indices, we can use this iloc. Okay, and then after that what we saw is we can also slice this. So we can say if we have data, so we can use data, then if you have this dot iloc, so we can not just we can slice it. So this is, if we put it like this, so this comma over here, so initially whatever is here is for the rows, and this over here after comma is for the columns. Okay, I think pretty much same with the syntax of NumPy. So here if this is if the dot is there, that means select everything. If dot is there, it means select everything. Okay, and then we can use the things again. We can we have one more thing. You can add the lists over here also. So you can add the list of the things over here. Okay, this is, so let me just show you that in the code so that you don't get lost over there. So that's the reason I am sort of summarizing these things, so you see where are we. So we are basically in the topic of indexing, how to index and how to select. So I said you can see, you can use dot I location, let's suppose. And now what you can do is, I am saying if I write it like this, so it will print everything. So if you see this, this will print everything. So if I am printing it like this, this will print everything. No, nothing is left. So now if I am saying print every column, and let's suppose print certain rows, so I can write it like this also. So I can say age, print age, let's say. Oops, iloc, we have numeric column, we need numeric, I have used iloc. So what I can say is, so let me just go it like this. So I can say start from 0 and go till, let's say 5, and use by default 1. So this is number of rows you have to select, and then number of columns, select maybe 0 till 2. Okay, and this is how it works. So you can see it. I chose age and sex columns, 2 columns over here, and then I said you select it from here, select from 0, and I can also add this step size. The same thing can be done over here. So I can use a list of these things also. So I can use the list with, but that should be with the location. So if I use this location, so what I can do is I can say select every data point. I think I also showed you this. Select every data point, but only select certain columns. So now I can say age, okay, maybe CP, because we have CP there also. So now if I print this, you can see I just selected this age and CP. So now you saw the difference between loc, and you saw difference between iloc and loc. Okay, then we also had Boolean indexing. Coming back, so I'll just keep on writing these things on the tab window also. So now you have access columns. So in the access columns you used the bracket notation. So I'll call this bracket notation. Use this bracket notation to have these columns, and then what you also use this dot. So dot column name dot a. So you can use this dot also to access the columns. Then to access these rows, what we can do is we can use this loc or dot iloc, and within that, this again is like slicing. So in that you can use it like these rows and columns like that, what you want to select. So you have this iloc and here rows and columns. So if you use now with this location, so what you can do is you can use these names directly, age, let's suppose, and then you can use sex, something like this, so which I just showed. And this will be again a list that will go, let's suppose, to the columns. Okay, and you can list, and then we said we can use the scalar things. We can select only one thing. So initially we were saying, okay, how to access these columns, how to access these rows. Then we can even select a single scalar. By scalar I mean a single value. So for that I showed you two methods. I showed you at and dot I at. Okay, this is selecting scalars, a single value. So you can just select a single value by using this at and I at. So I add basically means if you know the name. So I showed you 0th data point, give me it's this. Let's suppose 0 data point, give me the age of 0 data point. You will just write data frame df dot at, and then you will say give me the 0th point and its age. Okay, then you will get that scalar. And I add basically means if you don't want to use the name, you can directly use the integer indexing again. Okay, and then we saw Boolean indexing also. We saw Boolean indexing. Okay, in that we just made a Boolean mask, and let's suppose in the age was greater than some 50, and then we selected only we created a Boolean mask, applied that on data frame, and then we could select it. Okay, again showing you that so that it refreshes everybody's memory. So we said, let's suppose we have data, and now what we do, we'll create a mask first. So data of age, okay, is greater than 50. Okay, then I'm saying select this. So dot head, it will just create 5 points. Now you see this. So this is Boolean mask. Okay, so if I add one more thing, so I was trying to add that age, and let's suppose if we have this sex, and then this is equal to maybe CP I know is for sure there. CP is greater than maybe 2 or something. So I think I should add and here, because this is bitwise and. So dot head, this should work. It is not working, I don't know why, but it should work basically. So maybe I should do it like this. So if I separate it out, yes, I should do it like this, and I should. That's why precedence order matters. Okay, initially we were stuck in this. I tried not to debug it that time, but somehow it got stuck in my head. Oh, now yes, it works now. Now if you see this, I just added these braces so that internally this operation should happen first, because there is a precedence order. Okay, everybody clear with this? So there is a precedence order. So when I did not add this, it was giving me some error. So okay, suddenly it hit my mind that I should add these so that this thing gets evaluated first, and then this thing gets evaluated. Then it should perform the and ampersand operation. So if I take this, and these two are both series, I can perform this bitwise AND operation. So this is the mask I'll get. So if you see, this is the mask. Okay, now this mask can be applied on this data. So I applied this mask on the data. Okay, and after that I printed the head. So if I now see how many people are there who have age 50 and they have maybe CP, whatever it is, maybe chest pressure or something. So I don't know the medical term. So this is, and how many points are there, I can just say dot shape. Okay, dot shape if I print, I'll see how many data points, how many patients are of this type. Okay, now if you see this, so there are, this should not be head, because head will only give me 5. So I want without head. So 109 people are there which have age greater than 50 and they have the CP greater than 2. Okay, this was with the Boolean masking, and you can use these complex conditions also. It's not necessary you use just one condition, you can use complex condition, however you want. But remember one thing, so in here you should have a Boolean mask which is a series internally. So I told you one more thing, you can create custom things also. You can create custom true and false in order to select. Okay. And after that, what we saw slicing also. How can you slice? Okay, you can slice in the similar fashion. You can slice by using this. Okay, you can slice by using this, and then you can, let's suppose I want 1 to 5 data point, 1 to 5. This is slicing. So 1 to 5 basically means give me the first 5 rows. Okay, then you can as I showed you, slice by columns, by rows, and slice by this specific. And you can also query something. Okay, there is a query also. I wanted to show you that. So you can query this. You can say data dot query. So you can write a query. So query will look something like this. So age is 50, age, because we have this age is greater than 50. Okay, this is like a query, and sex is equal to 1, is equal to 1. So if you see, this is a query. So this thing is a query. So if you see age should be greater than 50 and sex is equal to 1, give me those points. So if I do this, so you get the columns. Okay, you have this method dot query method. Okay, and you can query some other thing. So like so FBS is equal to 1, and maybe and or you can put or also. So if you see, this is like SQL queries. That's why I call it query. If you see structured language, there we have this select this and select star from this table. So here we can use this query. You just have to write the method dot query or FPS FBS is equal to 1. Okay, now you see there are 156 rows, 156 data points. You can write a complex query over here. Okay, if you know SQL, you know how to do this. Okay, these were more or less the methods that we saw. I just summarized most of the methods, and we added this query thing. And then earlier we couldn't get this AND working. Now I told you that this AND can work if you just put these bases right. Okay, because of the precedence order that we had. Okay, and then we saw how to read files. We saw you can use head, you can use tail, and then you can print different stats, you can print d types, you can use value counts. We saw a lot of these things. Okay, and you know the difference between the view and the copy. Okay, here if you see these all things, these are the view things. But if you change, okay, if you change, it should happen. And you can, but why I was taking those scalar values, now you can change these scalar values also. So if I say data, now if you see this data, this is the data. So if I want to change this place, if I want to change CP, so what I can do is I can say data, and then I want to change dot at, maybe I at, I'll say I at 0th position, and then it's 0, 1 and 2, 0 comma 2, 0 comma 2. So this will basically select this, and I can assign it value. I can assign it value 4. Okay, I can do it like this, and then I'll say print of the data. I'll say print the data. Now you saw that I got the value 4 over here. Okay, I can reassign the values basically. So by using, because this is just the selection. So I selected that scalar value and I assigned it manually. Let's suppose sometimes while data collection, what can happen is some people mistype the values, and you can clearly see that this value should have been this, and you want to modify the value. So this is how you can modify. I just showed you how to modify scalar. You can add the row, you can add the column also. I also showed you. Oops, I showed you how to. Give me a second. So I was telling you that if we have to sometimes, let's suppose some human error was introduced while collecting data, and you want to change the data point. So you can use these IAT, and you can use the add functions and change the scale. I also showed you how to add one more column. Let's suppose what you want to do is maybe you want to add some total column over here. What you can do is you can do it like this. You can say data, and then just as we do in the dictionary, we can say this total, and then you can add any value, whatever you want, because there are let's suppose how many points are there? There are 303 points. I can use np.range, np.arange, and I'll create some 303 points, 303 numbers. And but initially I should import numpy. Okay, I should import this, import numpy as np. Okay, now if you see this, so if I print data now, there should be one more column added to it. Okay, now you can see the one more column is added, and I added values 0, 1, 2, 3, 4, some 302. This is how you can add. And now one more thing is you can drop also. Okay, sometimes you need to drop. There is a method literally drop. It is named as drop. So you can say data dot drop. Okay, if you see this, so data dot drop. If you now you can write the column names over here. So if you want to drop something, so you can drop the column. Let's suppose I'll drop the column. Let's say age. You can drop along the axis also. Oops. Age is not found in this axis, so you have to tell the axis also. So maybe axis 1 or something. So axis, this is 0 and this is 1 axis. Okay, now I have dropped the age. By default, axis is 0. Okay, axis 0 means if I want to drop this, I can drop, let's suppose, second point, but I should give axis 0. Axis 0 means the vertical thing. Axis 1 means the horizontal thing. So I dropped the age now. If you see, the age is dropped over here. So I can drop, let's suppose, this CA also now. CA is this column. If you see this CA, this is the CA column over here. So I can drop this along axis 1. If I want to drop some point, I can drop point number 301. Okay, so but I should give the axis 301, let's suppose. Okay, I dropped this point 301. You can directly see now point 300 and point 302. I don't have 301 points. So I can drop the points like this or columns like this. Okay, and then if there are none values, sometimes while I told you there are missing values. Okay, in the deep learning class I have given you a task which is called as maybe classification with missing values. So sometimes while collecting data, what happens? You don't have values for everything. Okay, you have these missing values. You can also check for the missing values. So again, to just write it on the tab so that we know what we have studied so far. So we have seen accessing columns, then accessing rows. There are two methods, brackets and dot, and then we have seen by using this dot iloc and loc. Then we saw selecting a scalar by using this at and iat. Then we said we can use Boolean indexing, and then we can use slicing also. We saw slicing as in NumPy. As in NumPy. So whatever NumPy has, all the things you can do over here. So then we can see you can add or change the things. So I told you if you have to change scalar, you can use I at or at to just select that element and you can change that. And then you can add a column also. You can add a column. You can add a data point also. If you have data point, you can add that. Okay. So and even after that, I showed you how to drop things. So you can drop the things. If you have to drop a column, if you have to drop the point, you can accordingly do that. Okay, and then I showed you query also. So I forgot to write this. So I showed you dot query method. So if many of you might know SQL, so I showed you if you can do like this. You can say data dot query, and then you can write your query inside, and then it will be parsed, and then whatever you want, you can do that. Okay. So and you can combine both of these things. Now you can combine this positional and label based indexing. So whatever positions you can, and then the labels, basically iloc and loc, you can combine both of these also. Okay. And now coming to the much important part which you will use maybe. So now you have to select. Let's suppose you have this data now. Okay. Because that also comes on the topic of selection maybe or the sampling. So let's suppose you have this data. I told you there are two phases in machine learning algorithms. So there is one called as training part, and there is testing. You have this data. I'll make this data like this. So this data is like this. Okay, so this is your whole data. Let's suppose. Okay. Now when you train the algorithm, okay, listen here carefully because this concept will be used again and again in machine learning. So what we basically want to do is, so if you have data, so we assume this is the data, and this data comes from a distribution. I don't assume right now you know what distributions are. We'll see that in the probability. So consider that there is something where the data comes from. So we call that data distribution. Okay, if these are let's suppose images of humans. So images of human come from a distribution. If you see these patients right now that we are dealing with the patient data, these patients they follow a certain distribution. Okay. Now if this distribution skids, then there is no point. By what I mean by skidding this distribution, if you train the model on one distribution and you test the model on and some other distribution, then you will see there is a disparity in the results. So what we do is we take the data, so we'll split it. Okay, we'll split this data usually in the three sets. Okay, we will have a training set, and we'll have a validation set, and we'll have a test set. We have three sets when we split the data. So we'll have training set, we'll have validation set, and test set. So this training set will be used for training. So if you remember that machine learning algorithm lecture, I told you that there you give data and the corresponding labels if it is supervised learning setting. Okay, and consider this machine learning as black box for now. Okay, we don't know anything about it, but just we know that we have data and we have corresponding labels. We feed this into the machine learning algorithm. So what will happen is it will come up with a program. It will come up with a program. Now this program will be given the new input, new data, and this should give us new labels. Okay, so this part I told you is called as training, and this part is called as testing. Okay, so this is called as training and this part is called as testing. So in training, what should happen is data should be given, but you should not test on the same data that you gave in the training. Otherwise you might feel that model might have memorized the thing. So if model is memorizing, if you see that your training accuracy is quite high, that in model is performing quite good in training, so but while you are testing it, it is performing terrible. So you call this model as overfit. So this model is overfitting. Okay, it is not, basically we want generalization capabilities. Generalization. By generalization I mean you should give it new data and it should be able to perform good. Then there are terminologies called overfit, underfit. We'll see them once we go to the machine learning. But here if you see, this is one of the phases. So you split your data. So you have the data, you have whole data with you. Right? Let's suppose right now we have 303 points. So we'll keep some points for training, and why for the validation? Because we have some hyperparameters. So we want to tune them. So what we do is we use training, then we test on validation and set the hyperparameters. And then this test set is never shown to the model. Maybe validation and training is shown. For training, we get the model, and then to tune the parameters, we'll show this validation set. Okay, and then we'll get the best validation, what's called as best validation loss and best validation accuracy we'll get. And after we are done, after we freeze the model, we are saying now we are ready with this model. At the end, we'll test it, and this test data should not be shown anywhere. If you show it, then it loses the purpose. Otherwise, you will use this test data and maybe tweak and tune your model according to this test data, and you will get high test accuracy. But this test data should be used at the end. That's why if you remember those stages of the machine that I told you, so there is the training, then we have the validation. So in validation, we tune these hub parameters and maybe rerun the model in certain ways. Okay, now this task was done by, I'll tell you, like, there is a good case study by Nokia. So what they did is they trained their face recognition system, and in Nokia phones they had the camera, and they wanted to have an ML model where it could recognize human faces. But they trained the model on European people, white-skinned people, and because these mobile phones were used all over the world, it couldn't detect these the people with the black faces and with the different structures than European people. Why? Because the distribution got shifted. That's what I said. The distribution skid happened. So the distribution was of European people. But when the phones were shipped to some other countries, what happened there is it couldn't recognize the face. So that's why this sampling is very important. This sampling of the data is very important. So you should have variety of samples. Okay, so that when your machine learning model is learning, it should not have the samples which basically are repeating in nature. So it should have variety of samples. So you must know how to sample the data correctly. Okay, there is a field called active learning. There's a field in machine learning called as active learning. So active learning basically tells you how much is the difference, how much is the difference between two samples. So if you take the two samples, it does not basically give more variety. So active learning gives you those samples in which there is more variety of the samples. So that's why I said most of the time you will use this data processing, and you will try to create as much better data as possible. Otherwise, garbage in, garbage out. You will give the garbage to the model, it will give garbage in the output. So you have to keep these in mind. So now you can also sample this with this data frames. So what you do is you have a function called data.sample. So I'll show you it in the code window. Now you have these 303 points. Now what you want to do is you want to maybe create a test set and validation set, and let's suppose you want to create the training set. Suppose we are saying we want to create train data. So what you can say is we have this data. So now we want to split it. So I'll say data.sample. Okay, data.sample is the function. And how many samples do you want? You can write the n. N is equal to, let's suppose we want some 200 samples for the training. Okay, so if you see, this is my train data now. So I have split in certain ways. I said train data, sample. So these many samples I want.
We cannot see the screen.
Oops. Oh, sorry. So I said, let's suppose you had this data initially. So I have this data. So if I just print it, so this is the data. I have 303 points in that. Now I need to split the data. I should have my training set, my validation set, and I should have my testing set. So for that, what I'll do is I'll create train data, and then I'll say, let's suppose this data dot sample, and then how many points I want, let's suppose 200 points. Okay, now if I run this cell and if I run train data, if I print train data dot shape, so you can see that I now got 200 points. Okay, so now if I want my validation set, what I can write is I'll write validation, okay, and then I'll say data is equal to data.sample dot sample, and I'll say n is equal to some 50 points. Okay, and this is that. So here if you see, these things are randomly sampled, but when you split, there should be no overlap. You have to consider the overlap should not be there. So I can also use rather than n, I can use fraction. I can say test data, and I can say is equal data dot. So what I'll do is I'll now write sample again, but now with the argument fraction. Initially I was using n means number of data points. Now I can use frac the fraction. So you can see the parameters over here. N is optional, so it takes n number of items from the axis to return, and then fraction and float option. So fraction of axis items to return. Then replace means allow, disallow sample of the same row. Should we allow it or not allow it? If you just by default it is false. If you want overlap should not be present, then you have to set it false. Then there are these weights, and then there are these random number generators also. If you want to have a seed, you want to have the same number, and you can read the documentation. So it is better here. So let's suppose here 250 comma, you should say replace is equal to, replace is equal, by default it's false, so it should be kept as false. So you should not give the replace. Okay, replace is equal to false, and then here I'll say fraction. So I want how much fraction? I want maybe 0.1%. Okay, out of 100%, I want 10% of the samples to be in the test. Okay, this is my test, and now I have created these three tests. test data, train data, validation data, and test data. Okay, these are 50 points, some 200 points, some 0.1 fraction. I can also use this and how many number of points I want. Now I can feed this data to the machine learning. So what I'll do is with this train, I'll train the algorithm. With the validation, I'll set the parameters. So I'll test with using the validation first to see can I tweak something in the model. So as to get the better, what's called as training accuracy or training loss. Can I get better training loss? And after that, once I'm somewhat locked, I'm saying okay, this is my training thing and this is my validation. Now at the end, I'll test the model. So I'll use this data to test. Okay, at the end, I'll say this is the test. So if it performed really good on training and it performed terribly on test, we call the model is overfit. So it is not learning, it's basically memorizing. Why? Because on training it is performing good. Once we give it a sample which is not from the training, so it is not giving a good answer. That means it is memorizing the training set. Okay, and there is a tussle between overfit and underfit. Okay, underfit basically means it is doing nothing. So underfit means it is not even doing good on training. So we call it underfit. So there is underfitting and there is overfitting. Then we try to find a model which is best fit. Okay, and we'll see this, what there is something called as bias variance trade-off. So we do this bias variance trade-off continuous to see if our model is overfit, underfit, and we want our model to be best fit. So I showed you how to sample these things by, if we have a data frame, how to sample the things and then train the model. Is it clear? Any questions on this? Okay, now coming back to the selection, so there are some other methods. The one method is method is called as is in. So this is also used in indexing. So indexing with is in. So I can say data. Okay, and then I'll again, this is some sort of Boolean masking again. So in Boolean mask, we use the mask for the data. So now what we'll do is we'll again say data. Let's say we have this feature CP because we know this CP is there. So I'll say only select those things in which CP has the value is in, and I'll say the values. The values are, let's suppose I'll say values are 1, 2, 3, 1, 2, 3. So is the if for a data point, if CP has the value 1, 2, 3, select it. Otherwise, don't select the points. Okay, then I can print it. Let's suppose I'll print the head. Okay, this is in. So how many points are there? If I want to see the points, so I'll just create dot shape. So now out of 303 points, so 280 points have the CP either 1, 2, or 3. So that's why this is in is used. So sometimes you need, so these values are allowed. I don't want other values. So I said, let's suppose age. So if age is 50, 60, or 61, something like that, I'll say age. So if age is either 50, let's suppose 50, and 60, maybe 50, I should write 52, and maybe 60. So I'll see how many points have either age 50, 52, or 60, and then I'll see. So there are 32 points like this. Okay, so who have either age of 50, 52, or 60. I can just keep one value on. So I'll also select only the values which are, but this is not the optimized use, because you can otherwise use that age is equal 50. So this is in method is basically used if you want to check for the multiple condition. This is like OR condition. We're saying data, age, or this or this. So now we don't need to use OR, because otherwise we're using those cascading operations. It's better to use this as is in. So this again is equal. So if you see this, so this, if I create a shape of this, so you see 7 points are there who the people who have age 50. So what I can do is I can also do it like this. I can do it with Boolean masking. If I cut this, so I'll say is equal 50. Okay, this is equivalent to what we wrote earlier. So initially what we wrote earlier is this. So this and this is equivalent. So if I just put it is equal 50. So they will give the equivalent result. Now if I print both of this, I should print the shape of, initially I'll comment out this, print this. So you see 715. So if I comment the earlier one, now print this 715. So these are equivalent. So now if is in, this is also equivalent to OR condition. Why? Because it's checking for the OR condition. I can write it like this. Data. So if you have seen Python videos, there we saw these bitwise operations. There we saw these operations which work on bits. So that's why I can turn it like this. Age, okay, is equal to 50. Okay, or how to write bitwise or like this. Okay, data, again age is equal 51. Okay, so if I, now the one careful thing that I told you, you have to put these parentheses so as to respect the order of precedence. Otherwise it was giving us errors. Okay, so now if I see this, so this is the data. So how many points are with the age this? So dot shape. So there are these 19 points. 19 points are there. So I can write it with is in. So how to do that? So I can say data of data. and then age. So I should put in quotes because it's a string. So that I'll say dot is in. Okay, so what is it in? So it should be either 50 or 51. 50, 51. So again, I'll just put dot shape. Now you see both of these commands are equivalent. Now you see 19, 50, 19, 50, equal number of points. So, but is in, it gives you more flexibility. Here you see that you have to check for this, and then you have to perform OR conditions. So this is implemented in optimized manner. So it is better to use this than to use this. Okay, and you can time it also. You can check and you can just time both of these operations and see how much time does this take. Okay, should we do it? I think in Jupyter Notebook it does have that time it. So time it. So why it does not give any time? So it should give. Maybe I'll again look at the documentation. So it is better not to look at this. So you can time it. You can time this in the Jupyter Notebook if you want to see which operation is performing first on the real-time hardware that you are using. So you can use this time it, and I think in some of the sessions, previous sessions, we also wrote a program to compute the time. So we said import the time and then see the start time and then see the end time and then see how much time does it take. And you can do the same thing with here. So I was hoping this time it should work. It should give me something over here, but it did not. But you can check it. You can check which operation is faster. Okay, I hope this operation will be much faster. That's why they give this is in. Okay, so they have optimized it in. They have implemented in optimized way. Okay, this is in. Now we have one more thing, that's where. Okay, so this where method, it's used to replace the values that do not satisfy a particular condition. Okay, if you have a particular condition and that is not satisfied, so you will basically replace these values. Let's suppose what we can do is we can say df, again this data, and then the age. I'll say this age dot, then I can put where. This where is the method. Oops. So dot where, this is the method, and then what it does is it will say will give a condition. So condition will be df. So where this age, again I'll put it like this, age. So I'll say age is greater than or equal to 50. Greater than or equal to 50. This is not df, so I keep on writing df data. Now good, it is giving me underline because I removed that df part. Okay, so I said data age dot where data is greater than 50, and then what should I do is I should replace it with something. I should say comma other. Other should be an option there. So this is where part and other np dot nan. So let me write this is not a number, np dot nan, and then I'll import this numpy. It is there, it's already imported. So if I print this, you can see. So wherever the age, let's suppose is this, so you have replaced this with based on this condition. So I said this is a method where it is used to replace where values don't satisfy a condition. So this condition, wherever this is satisfied, if age is greater than 50, keep it there, otherwise replace the thing with nan. So I replace this with this. I can replace it with any other thing. So if you see, if I now print the data, so I'll print data.head, I'll see if it is in place. So I'll tell you what in place means. Data.head. So age column is here. This is not in place operation. So in place basically means it is not doing the change within the data frame. So this is a temporary change. Okay, so this is not in place operation. Okay, so if you want to do it in place, so you can maybe create a duplicate copy and then add this column over there. So this over here, if you see, this age did not get actually changed. So age is still there. So this 37, it did not. But if you see it over here, so 63, 67, 67, and after that we had this 37, it got changed in nan, but it is not in place change. Okay, but you can do the in place change also where the change happened in the actual data set, but it is very risky to do in place change. Otherwise, sometimes you expect that my data frame is intact, so it is better to create copies otherwise. So I told you there's a difference between a view and a copy. What is a view? The reference is the similar. So if you want to create a copy, you know how to create copies. You have tried dot copy. Okay, otherwise this will create views, and whatever change you make somewhere, it will be visible everywhere. So it is better to create the copies if you are playing with the data frame. Okay, sometimes I have created terrible mistakes in my experience where I did something with data and I forgot to create a copy. And sometimes the data, it takes a lot of time to load. Let's suppose your data is having millions of points. It takes a lot of time to load, and you did something and it changed the original data. So it is better to create the copies when you are doing this expert data analysis. Okay, is it clear? So we saw a lot of these methods now. And we can have get, there are a lot of methods. Get method is also used. So if you want to get something, it's like dictionary. So I won't show you those methods, But one more important thing is that you can reset the index. Okay, you can set or reset the index. Now if you see this, so let's suppose you have this and let's say I'll create this data. So this data.head, if I print it, so here if you see, this is the data, and now you can, what I said, you can reset the index. So what you can say, this data dot, so there is a function called as set index if you want to set index. So set, and if you see, index is there, so this is there, data dot set index. So what you can see is, you can give an argument, let's suppose age, and then you can say do it in place. In place basically means, do you want to change the same thing? So data dot head. Okay, now you can see this age got over here, so I set an index separately. Okay, this is I made this age column as the index. I said age column is my index. Now I can also do it with the name. Let's suppose I had name, but I did not have name here. So if I had name, I can make that name as index. Okay, now you see, this is my index, and all of these are features. So by index, I can maybe select the rows. Okay, I can select but this usually index should be unique. So here index is not unique, but keep in view, index should be unique so that you can have the access to each data point. So this is a bad idea. I did it like really badly. I should have not taken age, but I had no other choice. If it was name, so I would have taken name, because usually index is used to uniquely identify the whole data point. Okay, so that's why by default index is either by default index is the set of integers starting from 0 to the n-1. Any questions? Yes, so I was talking about adding. So initially, now what we do, we'll create a data frame. So in here, if you see, I have created two columns. So age is a feature and sex is a feature, and all of these values, if you see 34, 21, 45, these are the values in these rows. So now if I print this df, so if I print this df, it looks like this, which I showed earlier. So this is 0 to 4, that means these number of data points, and then we have age has this value and sex has this value. If I want to additionally add one more data point, so what I can do is I can add like this. So if I have this cholesterol basically is a new data that I want, new feature that I want to add in my data. So I'll just have this df cholesterol and add these data points. Okay, add these values for each data point. So, and if I now print this, so you can see this, I just added this cholesterol. So df, and then run this cell, so you can see I had this cholesterol. So this was when I had a completely new feature. So sometimes what will happen is you want to add a feature which you can derive from the other features. Let's suppose you want to multiply age by 2 or something like that, and you want to maybe take square root of age. You want to do something with it. You want to do something with a feature that you already have. So you can also do that. Okay. So maybe let's suppose we want to see age in months. Okay, because this age in maybe in years. So how to take it in months? We can multiply by 12. So now what we'll do is we'll say data. So what is this is df, and df, what we want to do is we want to add one more column, maybe age in months. Age in months. So here now what we'll do is we'll take the data frame, and from that we'll take age. This age is there because we know this age is an integer. Okay, if you can check that by using this df.d type, it will show you that this is integer. And now what I can do is I can multiply it maybe by 12. Okay, then if I see this, now if I print df, now you can clearly see that age in months is this much. Okay, if this is an age in months, you can put a square root. If this already is in months, I can have the real age. So this is again addition based on some other things, based on the earlier features you had. You had some earlier features and then you combined them in some way. This is called taking a linear combination. So you took a linear combination of these features and you added some more features. Sometimes adding more features adds to the additional knowledge. Okay, sometimes we have algorithm, we want to curate more features. This is part of the feature engineering. Okay, because you have some data and you want to maybe combine certain things. Okay, let me take a real world example. Why will you use it and why did I show this? These things, this discussion will help you a lot once you are doing it in the real time. Okay, and then you will feel the value of these discussions. So what I'm saying is, let's suppose you have certain features. You have this feature 1, feature 2, feature 3, and feature 4. So what you do is you are saying that if I do something with a feature, if I add some features over here, my usually this machine learning models become better if you add good features. So what you can do is you are saying that I'll do something with this. I'll take a combination of these two, 3 features. So you can do maybe a linear combination or a non-linear combination. You can take a combination of features. You will add these features on. So in the hope that once I give it to the machine learning algorithm, so what will happen is, because now I am giving more variety to the data. Okay, maybe this data f1 and f2. Okay, so this data was there. From this f1, f2 features, I am doing more feature engineering. This is called as feature engineering. So I am adding more features. having the some knowledge about other features, I am taking some linear combination. I'll maybe, let's suppose 2 multiplied by f1 plus square root of f2. Let's call this feature f3, and we cannot maybe name this feature, but in practice you will see that such features perform good. So these sometimes are called latent features. So what is the meaning of latent features? Latent features means that you cannot name them. Okay, but these do perform good. So these latent features do perform good. So you can just add these features. Like suppose we have this feature now. Let's suppose f3 dash. F3 dash is a feature which is a combination of some other features, maybe linear or non-linear combination of other features. So, but if you add this feature, in reality, what you do is you see that your model performs better. So it is better to do these feature engineering. And many of the things, many other people, they do this feature engineering. So you augment your data. You have some base features, and then what you do is you combine these features in a certain way to come up with these hybrid features, which I'll call as latent features. If you don't have a name for them, you'll call them hidden features. And if you see that your model is performing better, it is good to include these features also. Okay, I hope that you got my point of saying you why do you need to add more features. Okay, coming back to this code. So now you saw we saw two things. First, if you want to entirely add a new column, so that is maybe you got new features and you talk to domain expert, and then he said, okay, this feature is good, you can include this also. Sometimes as a part of feature engineering, you don't want to include an entirely new column, but what you want to do is you want to take a combination of what earlier features were. And if you do that, you can maybe multiply, take a linear combination, non-linear combination, and you add one more feature in the hope that once I give this feature, my model will maybe become better. So maybe sometimes what you do is you can add a constant thing also. Let's suppose for that I'll add this df, some maybe let's suppose country. If everybody is from India, let's say, so I'll add this thing country. This is a constant, so it will do one thing. It will paste it or all the things. Now if I print this, so now df, if I now print the df, so this column will be their country now because I have a constant value. Now constant value will be broadcasted through over, because we have already had a discussion on what broadcasting is, what vectorization is. So here the value is broadcasted all over. So because it knows we have these many number of points, so here we had 4 points, so this country is broadcast everywhere, and otherwise we have just defined India once and it is broadcast everywhere. Okay, is it clear? Then you can also have, you can add multiple columns also. By multiple columns you can do it with data frames, simple data frames. So I don't think that is much difficult. So what you can do is df, so df and then select this. Let's suppose you want to add something else. You want to fbs because we had these features, and one more feature we had is cp. So we want to add this also, cp. So if you want to do multiple things together, you can do that also. Okay, you can add multiple. So we are adding columns right now. We are not adding new data points. We are right now adding new features. So we are in the feature engineering part. So what you can do is you can write pd again dot data frame. I think coding window is visible. Yes, it is. So what we'll do is we'll create this data frame, and with these features. So if I just copy the values over here. Any questions? Any questions on this? I can hear somebody unmute his mic.
I think we need to use the data.
No, yeah, no. I created data over here. Yes. So I actually created this data frame over here. If you see, I created it here. So this is not the original data that I was working with.
Okay.
So this I created manually because now I'm not working with the data that was in my system. So I created it on my own, and then I said if I want to add more features. So right now we are adding the features. Okay, and this is in the part of feature engineering. Once you have a problem and you see these features, and somebody came up with new features, and you are now trying to combine these features with the earlier ones. So initially we were adding one feature at a time. Now I said that you can add multiple columns also. You can add multiple features at the same time. So this is how you can do it. Okay, now if you just print df, so you'll see this fbs cp. So this country, so we added age in months. This was one. So initially I think we added cholesterol. Cholesterol was just one feature that we added. Then we added age in months. This was derived feature. So this is not the actual feature. This was derived from the features that we had. Then we added this country. So country was a constant feature. If you want a feature which is throughout same. Then we added this fbs and cp. We added them together. So if you want to add two things. Now the point is, can we add new data points? Okay, we added new features to data. How to add the new data? How to add these new data points? So that's quite easy again. Okay, so Pandas gives us the methods to add new data point, and there should be method. Okay, now how to do that? So what I can do is I can write new data point, something like this, new data point. And now I know that what are the column names, so I can accordingly give those. So I know I'll create a dictionary sort of thing. I'll say age, this is my key, and I'll give the value 32, something like this. I now have there is this sex. If it is there, I'll have to see yes it is. So I'll have to give the value. Let's suppose 1, and then maybe I'll give this value of cholesterol. Is the cholesterol there? Yes, it is. Cholesterol level, and then I'll have to add some value over there. Let's suppose 230. Okay, and for other values, let's suppose I did not take the data. So what I'll do is it will have not a number value. So now what I'll do is I'll say df.append. So here you were seeing that we just did it like this, df, and then we are giving the column names. Now if you want to add new data point, there's a function append. So we'll have to give this df.append. So now it will append, and now we'll say new row. Okay, new row, new data point, or new whatever the point we named it, and then we can say ignore index. Okay, and ignore index basically means don't care about the index. So I'll say ignore index is true. Ignore index is, let's suppose, true. Okay, and we don't want to insert it in the certain index. We want to ignore that index. Give me a second. I'll run it now. So new data point. Data frame has no. So do we have a problem? So df.append. Oops. If it does not have append, we'll have to look at the other data. Maybe this is a particular pandas version, so it might differ from version to version. Okay, I am following a documentation which may be of the particular version. You will have to find this. So I'll see if the append method is there. Give me a sec. I'll pause the recording here. I'll see if this method is from some other version. So finally, after searching, we find that this append is depreciated, and what we have given is they have given this concat. So now how to append these two things? So if we have series 1 and series 2, let's suppose S1 is series 1, so this is series 1, and you know how to create the series, and then we have these series 2, and if you want to concat them together. Okay, and this is series 1. If I just print it first, so this is S1. So S1 is, let's suppose, this is 1. This is my S1, and this is my S2. If I print this S2. Okay, and this is my S2. S2 is C and D. So what I can do is I can concatenate them together. By concatenation, I can add more points. Let's suppose A was 1 point, B was 1 point, and C and D were 2 other points. So what I can do is I can write pd.concat. Yes, now it is appearing in my VS Code also. So how to do that? Now I have to say S1 comma S2. Okay, S1 comma S2 is basically append this, and then I'll again say ignore index. Okay, ignore index is equal to true. And this is that thing. So if you see, initially we had this S1, and then we had this S2. Now we have appended this. We have appended C and D. Okay, append is depreciated. Okay, and they have given the version. That's why I'm saying keep in touch with the documentation. Then you won't lose anywhere, because they keep on refining these things. They keep on adding these things. And append, as you showed that once we did that, this append, df dot whatever we had df dot append, it was not there. It is not even showing it here. So if I say df dot concat. Is it not? It is not even showing.
pd.concat.
Yes, PD, because it is not having the cell. I'll show you. I'll tell you the internal. So here, if you see the pd.concat, it was able to predict that. Okay, here is that. Here it is. So now you see this append is not working. So we got the method that is concat, and we'll see still how to join, how to merge. This is a separate topic. But here I wanted to just show you how to add one more data point. So now we saw two things. So first thing that we saw is how to add more features once you are doing feature engineering. But sometimes what you want is you want to augment your data. Coming back to this tab window so that I can make the things clear. So we have now two things of adding. So one thing we can do, we can add features. So we can add features. By features, I mean when you perform feature engineering, there what you do is you want more features so that your model becomes better, because I told you that if you have more better features, if you have a variety of samples, then your model learns somewhat better. Okay. And the second thing is adding more data points. So if you add more data points, okay, again it makes model better. So the assumption is that the more data you get, the more data you have in the data frame. So when you feed in a machine learning model, it learns somewhat better. And sometimes you call this phase as augmentation. Okay, and by augmentation you augment the data set. You had other data set and you augment it. Now this augment can be synthetic data. So you can augment data by using synthetic data. So what's the meaning of synthetic data? Let's suppose you have a very less data that is real data. So what you can do is you can synthesize data. So there are a lot of deep learning machine algorithms which create this data. Let's suppose you might have heard about GANs, generative adversarial networks, and you might, and now everything which has generative, it generates It synthesizes the data basically. So if you want to augment your data and if you want to add more data so that your machine learning algorithm or deep learning algorithm performs better, because the assumption is more the data you give it, it comes closer to the actual model. It comes closer to the actual predictions. So you want to augment the data. So one thing is you want to add features. Why? Because you want a variety of samples. Okay, that you can do. How to add that? We saw how to add these features. Okay, then if you have less data points, let's suppose here we had only 303 data points. So what you want to do is you want to synthesize data points by using deep learning machine learning algorithm. That is one technique. You can use these GAN, generative adversarial network. You can use diffusion models. You can use let's suppose some other models which may basically create synthetic data. Let's say we have image data. So one famous thing is usually you do it with images. So you have image data. So now you feel that this image data is quite less. Okay, now I want to augment this data. What you can do is with this previous image data, you can flip them. You can stretch them. You can stretch them and you can change the lighting maybe. Okay, you can make it dimmer or brighter or something like that. So you are doing something with the previous image and creating new data points, and that data points you are concatenating with the previous data points. Okay, you are basically adding those features. Okay, adding the previous adding these new data points so as to augment the original data set. So because the assumption is, so in both of these things, assumption is much better features gives much more variety in the data, much broader sense in the data, and more the data points, we get closer to the ground truth. So if you have more data, so then that's why if you see these large language models, now they keep on adding more data. Okay, they had initially they had, let's suppose, some millions of parameters. Now they have billions of parameters. Now they are nearly half a trillion of parameters. They'll go to trillions of parameters. Why? Because they are giving it more data, and then it is learning from the human feedback also. When you query it something, so it keeps on stacking that data also. The assumption is the more data you give it, the much better it becomes. And similar with the features, the good quality of data you give. So features will make good quality data. So if you have data in which you add better features, so that means you are giving good quality data. So keep in mind this. Garbage in, garbage out. If you have the garbage of data, so you will get garbage output. So irrespective of how much complex your model is. So again, same with the data points. So now you should have the data points, much more data points, so that it captures the actual distribution. So the term I should use is it has this actual distribution. Okay, I should, as I told the example with Nokia phones. So Nokia phones, these people trained the model only on European people. Okay, what the problem was, it was not a representative of the distribution. Okay, I use the term representative. Okay, there's a distribution. So usually we call it a sample. Sample is representative of the distribution. Let's suppose you have blood in your vessels. So you take a blood sample. That sample is representative. It represents your blood. So whatever metrics we measure in that blood, we assume that whole of the blood has those metrics throughout. Okay, that's what, when you sample a distribution, we assume that the sample should represent the distribution. It should be a representative distribution. So there is a theorem called as CLT, central limit theorem. We'll see what that is when we go to stats and probability. But here, to add more data points, we're assuming that we're getting closer to the actual distribution. The sample that we are having is of the actual distribution. That's why we want to append features and we want to append data points. Any questions on this? So now we saw adding of these features and adding of new data points. Now again, the similar thing is we can drop the features, and we can drop the data points. So why do we need dropping? Let me give you the context behind that. Why do we need dropping sometimes? So why do we need to drop a point or to drop a feature? So sometimes what happens is you have redundant features. Okay, let's suppose you have this feature F1 and you have this feature F2, and you have this feature F3, you have feature F4, and you have a lot of features. But what you want to do is, you know that the feature F1 and F2, it contains most of the information. Okay, so I need my data set to get compressed. So I need to compress the data set. By compression, I mean if I have irrelevant features added in that. So what I assume is, I'll say that this, if I can remove this F3 and F4, because somehow I can derive them from F1 and F2. Okay, so if I can do, this is called as dimensionality reduction. I'm telling you this we are doing right now manually, but we have algorithms to do that. We have algorithms to do dimension reduction. Like let's suppose we have algorithms called as PCA or TSNE. Okay, so these are the algorithms by which you do automatic dimensional reduction. So what is dimensional reduction? So you have these dimensions. How many dimension data we have? So let's suppose if we have 303 cross 15. So this means we have 303 points and we had 15 features. Okay, these are the features. And each feature is considered one dimension. Okay, our data is now, if all of our data is real value data, so we'll say this belongs to R of 15. So this data basically belongs to R of 15. That means each of the data point is represented with a vector, and that vector is 15 cross 1 vector. Okay. So, and these values are, let's suppose, real valued, if they are real numbers. I'm making a simplistic assumption. So we can say that we have 15 dimensional vector. So more the dimensions you have, more computation power is needed to process. So when you are feeding it to the machine learning algorithm, what will happen is you will have to have more computational power in order to crunch these numbers. So for that, what we can do is we want to reduce dimensions. We are saying, oh, there are 15 dimensions. Can I do this task with less number of dimensions? Okay, if I can do maybe comparably well, if I was getting earlier with 15 dimensions, I was getting accuracy of say 98%. Okay, if I am getting say 96% accuracy with say 5 features, so it is better to keep only those 5 important features. Okay, I'll see feature importance also, what features are more important, and there are algorithms to find what features contribute more to the accuracy, and there are algorithms to find the feature importance. Okay, so what you want now to do is you want to compress this data somehow. You want to drop these features. You are saying that I want to drop these features because these features are probably either not contributing much or unnecessary, and I have to, let's suppose, 15 features, and each feature is taking, let's suppose, 2 bytes. Okay, if I have, let's say, 1 million points, 1 million into 2 bytes, these many bytes you are saving. So these many bytes, if you are just dropping one column, you are saving these many features for if you have 1 million points. If you are now, let's suppose, dropping 5 columns, so this much memory you are saving. And you are not just saving the memory, you are saving the computational cost also, because this also requires a lot of computational cost to perform. So it is sometimes better to do these dimensionality reduction. Okay, but sometimes you do it algorithmically and you want to take most important features, only keep them, and sometimes you don't want to do it manually because sometimes you feel if you this F3 is redundant, I can remove this feature. Okay, this is nowhere to use it, and I can remove the features. And now we'll see how to remove the features. We have seen it. I'll just show you how to remove these features. You just write dot drop and the axis number. Keep in view that if you have this matrix, so this is my axis 0 and this is my axis 1. Okay, this is my axis 1. So if I have to remove a feature, so I should remove it from axis 1. So I have this function now dot drop. So what I'll do is I'll say df dot drop along the certain axis, and then I'll see what to drop. Okay, now going back to the coding window. Okay, so if I have this data, I'll print this df first. So this df, oops, this is, let's have this data. The data has these many columns. Let's suppose if I feel this old peak data, this is redundant to me, I can remove this. So I can call data is equal to data dot drop. So this drop usually is out of place. Out of place means it does not do the change within the same data. So that's why I'm assigning it. By force I'm assigning it. Otherwise it will not, it will create a view. There's a difference between view and copy. We have described that in detail in NumPy. So if you see data dot drop, so what I want to drop? So I want to drop this particular, maybe let's suppose, feature. So this is the feature I want to drop. Maybe if I want to drop more features, I'll just add features over here. Now I should write which axis do I want to drop it. So I want to drop it along the axis 1, because I showed you vertical axis is my axis 0, horizontal axis is my axis 1. So I'll just say axis is equal to 1. So I want to drop this. Now I'm assigning it to data. So this is showing that I am making it in place now forcefully. Otherwise this was just a view that was created. Okay, now I'm assigning it to the data, and this will override the previous data. Now if I print this data, so this is what I wrote. So if I now print this data, you can see these things are removed. So now if we see this, this is nowhere there, old peak CA is not there. How to even check? Because if there are a lot of columns, because you know there is a function columns, you can just see columns. Okay, tell me why is it giving this error? Can anyone tell me why is it giving this error? Can anyone tell me? Because IPython notebook works in such a way, because I earlier used this command. So I did this command, so it removed these things. So if I again am running this cell, so it does not see this old peak and say, because it was already removed previously. Okay, so if I have to do this, so I have to again read the data. So that is one of the problems with IPython notebook. You will have to take care. If I run a cell, it performs the whole thing in that global scope. And that's why when I ran this cell once, it gave the correct answer. If I ran it the second time, it gave me the error. Why? Because it changed that thing. Because now if I have to run, let's suppose I'll go back to the top where I was reading this data. So I was reading this data over here. So if I read this data, so I'm reading it. So now if I go back here, so if you see it over here, so this, now I'm able to remove it. Okay, now if you see columns, This is a column. Now if I run this cell again, it will give me an error. Why? Because the data has been changed. If I run this, I'll get an error. Okay, did you get the point? Why was I getting error the second time I was running this? How many of you got this thing? Okay, so this is why I got the error initially, because I made the change and I was running it second time. Okay, this is how we drop these columns, how we drop these features, and I told you the reason why to drop. And if you want to drop in place, you don't want to assign it like this. There is an argument in place. Okay, so if I just print the data, so this is my data. So if I want to do in place, I don't want to assign it, I want to do in place. So I'll just say data, and let's suppose I want to drop this. So I'll say data drop. So drop. So then I'll write the name of the column that I want to drop. Let's suppose I want to drop 6, and then I want to drop maybe CP also, but I want to do it in place. In place means I should not get a view, rather I should get the copy. It should happen in the same data frame that was there. So I'll say in place. In place is the argument. You can see it. I get it here, and then I'll say true. Okay. By in place, I mean that the change will happen to the same data frame. Now if I print the data, oops, there is some problem. Is there something? So is there CP is there? Yes, it is there. I have to give access also. Yes, so I have to give access. So I'll give access. AXIS axis is equal to 1 comma. Yes, now it worked. Okay, it was asking me for the access. Now if I print this data, okay, and now you can see this, these things got removed from access but in place. But you saw that it went in the data. I did not have to do an additional step of assigning the data back, because by default it is out of the place. It is having this in place as false, and it is making a new view. And if you want to do it, you can either assign the copy to the original, or you can just say in place is true. Okay, and then you can drop the rows. Now we have to drop the rows. Sometimes we feel the data points are redundant. Okay, coming back to the window and coming back to tab to show you why do we remove the data points. Now I told you what is the significance of removing the features. Okay, so one simple way is you want to make data simpler, and the second thing is you want to make your algorithm computation less expensive. So you can remove these features which you feel are less contributing towards the learning of the algorithm. Okay, that is the feature part. Now if you have to drop these rows, why do you need to drop the rows? And sometimes what will happen is you will have duplicate entries, or almost duplicate entries, or exactly duplicate entries. So you'll have to remove these rows. There is a separate function of drop duplicates. We'll see that. And then there is a separate thing if you have not a number values. So there can be a lot of things. So duplicate can be there. So there can be not a number values in a row. Let's suppose if you have data point, most of its things are not a number, or maybe its main feature is not a number. So we are saying it's unnecessary to process the data point. Let's leave these things where we have this NaN, where we have these duplicates, or which contributes very less. So what you can do is you can drop these rows. So how to drop the rows? Same thing. You can drop the first row, the third row, and write the x is equal to 0. So coming back to the code window, I think I showed you it earlier, but very briefly. So here if I want to drop, let's suppose 301 points. So what I can say is I'll say data dot drop, and you can see drop NA is also there. Drop NA basically means if it is not a number. So but right now we're focusing on drop. So I can say which things to drop. I'll say drop point number 1, point number 2, point number 5. Maybe let's suppose they are the points which are redundant. So after that, what I'll do is I'll say axis, because axis now is 0, because I'm dropping the rows. I'm not dropping the columns. I'm not dropping the features. I'm rather dropping the data points. So now if I just run this, now you can see that point number 1, because now this is not in place. So I'll have to assign it to data. Now you can see this point number 0 is there, 1 is not there. Point number 2 is not there, 3 is directly there. Point number 5 is not there, 6 is there. So we are dropping the different data points. Okay, you can drop the duplicates by using drop duplicates. Okay, there is a function drop duplicates. So what this drop duplicates will do? So it will automatically search for duplicates. Okay, so this function this thing has to be removed from the arguments. If there are duplicates, it will drop. Otherwise, it will do nothing. Okay, there are these dropping missing values. So we have drop NA. So you can also, if you have this not a number there, so you can drop NA. So we actually saw two things now. So we saw adding other features, and adding of these data points. Then we saw removing of these features and removing of the data points. And we had two important functions. For adding, we saw that we just, if you want to add a column, so in that we just add name the features, and then we had a quite good discussion on why to add features and why to remove features, and why to add data points and why to remove data points. Okay, so for today I'll close the session here. If you have any questions, I'll take that.